Welcome to This Explainer. Okay, today we are tackling something absolutely mind-bending, a concept that literally alters how you perceive reality. Have you ever just stopped for a second and wondered if the world around you, like the chair you're sitting in or the screen you're watching right now, is actually real? We are diving headfirst into the simulation hypothesis. We're going to systematically break down the science, the philosophy, and the hard numbers behind the wild idea that you and I might just be strings of code running on some futuristic supercomputer. Let's dive in. To start, we really have to question our baseline assumption that physical reality is just absolute. We rely on our senses to navigate the world, right? But we already know our senses are incredibly easy to fool. Just think about how optical illusions can completely hijack your brain's visual processing. Or take physics, for example. Every object you perceive as solid and heavy is made of atoms. And those atoms, they are actually mostly empty space. So if the fundamental building blocks of our world are mostly empty, and our brains are constantly misinterpreting sensory data anyway, what if everything we experience is just highly advanced trickery? And that exact question brings us to the formal simulation hypothesis. This was popularized back in 2003 by Oxford philosopher Professor Nick Bostrom. He dropped this fascinating scenario in a famous paper. Imagine a future civilization with basically unimaginable computing power. Now, what if our distant descendants decided to use that massive power to run complex ancestor simulations? These simulations would be so incredibly detailed, so high resolution, that the billions of digital people living inside them would actually possess real consciousness. They wouldn't even know they were simulated. Now, you've probably seen pop culture explore this, most famously in the 1999 movie The Matrix. The whole premise is Neo experiencing this massive shock when he realizes his life is split between two totally different existences. On one side, you have the fake, late 20th century virtual reality being pumped straight into his brain. On the other side, there's the real world, which is this dark, scuzzy physical reality where machines are farming human bodies for energy. The movie frames the physical reality as the ultimate truth, and the digital one is just a pure illusion. But is that actually the right way to look at it? Well, according to NYU philosopher Professor David Chalmers, we might have it all wrong. Chalmers argues that a simulated existence wouldn't be any less authentic than a biological one, and his logic's pretty hard to shake. He says, look, the computer running the simulation, that's real. The circuitry, real. The data processing, absolutely real. Therefore, a simulated life is completely authentic. It just happens to be built from computer chips and silicon instead of biological meat and neurons. It's a massive perspective shift. But philosophy aside, physics actually has a huge bone to pick with this idea. Let's move into section 1, the reality check and the energy problem. So, while a simulation sounds awesome in theory, an Italian astrophysicist named Franco Vazza published a paper in 2025 that throws a universe-sized wrench into the whole thing. The problem is energy. The sheer, incomprehensible scale of power you would need makes this almost impossible. If you want to simulate the entire visible universe down to the absolute finest detail, non-starter. It would literally require more energy than actually exists in the observable universe. Okay, so what if the simulators downsize and just render planet Earth? Vazza calculated that would still require converting the entire stellar mass of a globular star cluster into pure energy. And if they cheat, say they run a low-resolution Earth, the computing power is still so heavy, it might take millions of real-world years just to process a single second of Earth time. So simulating billions of people and a whole universe, practically impossible. But what if they don't need billions of people? What if, to save all that astronomical power, the computer only needs to render exactly one truly conscious person? You. Think about it. The only consciousness you can actually verifiably prove exists is your own. Everyone else, they could literally just be background code. We can call this idea the Truman Show limit, borrowing from that classic 1998 Jim Carrey movie. In that film, Truman Burbank thinks he's living a totally normal life, but he's actually stuck on a massive fake soundstage surrounded by actors. Only his experience is real. Everything else is rigged just for him. If our universe is a simulation, your direct experience is actually pretty localized. The computer doesn't need to render the whole galaxy at once, just the room you're sitting in, and the specific things you are directly looking at right now. But Vazza pushes back on this single-person loophole with something we can call the microscope problem. Because sure, a simulation focused just on you works totally fine, right up until you do a science experiment. The exact moment you look through a microscope at a living cell, the computer suddenly has to frantically render a whole new level of complex detail. Look even closer at atoms, and suddenly it's computing tiny electromagnetic processes. The simulation would have to get endlessly more detailed until it overloads its processing limits and crashes. Unless, of course, the single simulated person isn't a scientist and just never looks that closely. All right, let's jump to section 2, the math and the matrix. Specifically, statistical chicanery. Let's just put the whole energy crisis aside for a second and look at the mathematical probability here. Going back to Nick Bostrom's original argument, he laid out two main reasons why an advanced civilization might not be running these worlds. First, the fraction of civilizations that actually survive long enough to reach this highly advanced post-human stage is practically zero. Or second, the fraction of those advanced civilizations that actually care to run historical ancestor simulations is practically zero. Bostrom argues that if neither of those constraints is true, meaning civilizations do survive and they do want to run simulations, well, then they'd create millions of them. So mathematically, simulated universes would vastly outnumber the one real universe. Ergo, it's highly probable we're in one. But hold on, because that logic actually relies on a massive statistical trap called the inverse gambler's fallacy. First, you know the standard gambler's fallacy, right? You flip a coin, get 10 heads in a row, and you feel like tails is absolutely due. But it's a fallacy. The coin has no memory. It's always a 50-50 chance. Well, the inverse gambler's fallacy is a little different. Imagine walking into a casino, and the very first person you see is on this massive, unbelievable winning streak. A friend leans over and says, "Wow, winning is so rare. There must be thousands of other people playing in this casino right now just for us to witness this one winner." And that is the statistical trap. You simply cannot deduce the size of an entire population based solely on observing one individual. Translating this directly back to our simulation debate, we cannot mathematically deduce that we are in a simulation just because there could theoretically be millions of simulated universes out there. The statistical argument alone just doesn't hold water. Which brings us to Section 3, testing reality. Let's look for glitches in the matrix. So, if the math can't prove it, we're left with our final puzzle. Short of the laws of physics totally failing, how could we actually spot the glitches that prove our existence is simulated? Well, thinkers have proposed a few physical clues. First, there's the finite speed of light. What if light speed isn't a natural physical law, but is actually the absolute processing speed limit of the computer's hardware? Then, look at the fact that our universe is made of quantum elementary particles. Could that mean our reality is quite literally pixelated at the lowest possible level? And third, Professor Melvin Vopson suggests we might actually be able to detect the disappearance of information when elementary particles annihilate each other, literally like data being deleted from a hard drive. But here is the real catch. These might just be the exact ways a purely physical, non-simulated universe naturally operates. It is incredibly hard to tell the difference. Now, on the flip side, there are mathematical attempts to disprove the simulation entirely. Researchers Mir Faisal and Lawrence M. Krauss look at Gödel's incompleteness theorems. Basically, these theorems prove there will always be unprovable statements in any mathematical system. Faisal and Krauss argue that because there are uncomputable physics in our universe, like the insanely complex behavior of a black hole, those things simply cannot be run by an algorithm. The logic is, if it can't be computed, we can't be inside a computer. But definitely worth noting, this is all purely theoretical right now. So what would actually be the smoking gun? When Nick Bostrom was asked this, he injected some pretty great humor into the debate. He suggested the most undeniable proof would simply be the simulators intervening directly. Just imagine walking outside, looking up at the sky, and suddenly seeing a literal giant pop-up window hovering in the clouds that just says, "You are living in a computer simulation. Click here for more information." Or maybe they just physically lift you out of the simulation into their base reality. But short of that, definitive proof is incredibly elusive. But let's say we could design the perfect experiment and prove it. Bostrom offers a pretty chilling twist you might want to consider before you turn that machine on. If an advanced civilization is running a blinded simulation for research, and the simulated subjects suddenly figure out they aren't real, well, the experiment is compromised. Bostrom notes it might actually be a terrible idea to run that test, because the simulators might just decide the project is ruined and completely pull the plug on us. So to wrap this all up, for something to be a true scientific hypothesis, you have to have a mechanism to gather hard evidence. And by that strict measure, the simulation hypothesis isn't really science just yet. But even without a way to test it, it is absolutely one of the most fascinating thought experiments of our time. It forces us to question our senses, our technological limits, and our entire place in the cosmos. So as you go about your day-to-day, touching solid objects, looking up at the sky, I'll leave you with this.
How much of your daily experience are you taking for granted? And what would you do differently if you knew for an absolute fact it was all just a line of code? Thanks for joining me on this explainer, and keep questioning everything.